everyone. I'm Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. In this March 2026 lecture series, we are going to discuss about thermoelectric thermocouple in pressure, displacement and temperature transducers. Okay, first of all, why do we need to study this topic? Actually, our real world biomedical problem is we need accurate temperature monitoring because we need to give a proper patient diagnosis, treatment, and monitoring in healthcare settings. Actually, here healthcare settings means the settings which we provided for our biomedical instruments and clinical applications. And the impact is, if it is not solved, means misdiagnosis and incorrect treatment may occur, and delayed detection of fever or infection, it may lead to serious scars, and compromised patient safety may occur. And here, who is affected? The affected elements are the affected persons are patients, clinicians, and industry. See here, the need for solution is a limitation of existing methods. Already we have mercury thermometers and infrared thermometers. Mercury thermometers, the response time is slow and toxic material and a limited range and not reusable. See here, in infrared thermometers, inaccurate at distance and affected by ambient condition as well as the surface temperature only. It detects only surface temperature. The clinical challenges are continuous monitoring, invasive versus non-invasive, physiological ranges, and rapid response. Here, the technology gaps which reduces the system's performance, which includes miniaturization, smaller implantable sensors. It is effectively used for our body area. See here, for example, in body area network, we need a small size miniaturized sensors for communication purpose. Same, there we use small type of antennas for communication purpose. And wireless transmission, it enables remote monitoring capabilities and low power consumption. We need low power devices for power consumption, low power consumption, and we need high accuracy. For example, plus or minus 0.1% for better precision. See, what is a thermocouple? A thermocouple is a temperature sensor. It is made of two dissimilar metal wires joined at one end. Here, what is Seebeck effect? The temperature difference between junctions generate voltage proportional to temperature difference. This is called Seebeck effect. The voltage proportional to temperature difference is Seebeck effect. See here the thermocouple temperature measurement. See, in Seebeck effect, when two dissimilar metals are joined and a temperature difference exists between that two junctions, the thermoelectric EMF is generated. Here, the equation is E equal to alpha T1 minus T2. E is your EMF in volts, alpha is Seebeck coefficient, and T1, T2 are junction temperatures. T1 is junction 1 temperature, T2 for junction 2. Here, the diagram illustrates the semiconductor thermocouple Seebeck effect. See, the signal flow is temperature to thermocouple to signal, which is represented in volt, and finally signal conditioning. What is the purpose of signal conditioning here? We need to get a proper amplified signal, proper strengthened signal. So we use signal conditioning circuit at last. The output of signal condition is a perfect amplified strengthened signal. See, thermocouple construction types. We have iron constantan and chromal aluminum and copper constantan and chromal constantan. Here we use different kind of materials for enhancing the accuracy and precision of clinical applications. See, thermocouple signal conditioning. We have cold junction compensation. After that, signal amplifier for signal amplification. It increases the millivolt signal to measurable levels. And linearization, it converts non-linear voltage into linear temperature. Then instrumentation amplifier provides high gain, low noise differential input, and digital signal processor, it computes temperature from voltage. Finally, low pass filter to remove the noise and interferences. From thermocouple to CJC. This is your cold junction compensation, amplifier, linearization, analog to digital converter, then display. See the biomedical applications of thermocouples. We have a variety of applications: body temperature monitoring, surgical procedures. We use thermocouples for medical equipments, research and diagnostics. Here the main advantages are high accuracy, fast response, wide range, miniature in size, cost effective and durable. See how do we integrate design thinking concepts with our topic. Here empathy, understanding the healthcare problem regarding temperature monitoring. Define how do we design a temperature monitoring system that is accurate, reliable and safe. And ideate part, we have miniaturized thermocouples, probes, wireless transmission, smart alarms and near-chair integration. And at last, clinical validation, data analytics and system integration. Here we have to ensure patient comfort, high accuracy, low power, fast response, wireless connectivity and safety. See here I've included one student activity, think, pair, share, an interaction activity. And here I've included assessment questions from GATE and industry. First one is to calculate EMF generated. Second one is thermocouple selection for body temperature. Here is the summary part. Here what we have seen today is principle, Seebeck effect, EMF generation and TV relationship, temperature voltage relationship, signal conditioning and types, then biomedical applications, which involves body temperature, surgery monitoring and medical equipments. Here these are the references for our topic, thermoelectric thermocouples. Thank you.